Good day there, math buddies. Welcome to my YouTube channel. And today, we will learn all about combined variation. Of course, we will be guided with these objectives. And these are: first, to define a combined variation. Second, translate mathematical statements into equation. Third, solve for the constant of variation. And fourth, solve word problems involving combined variation. But first, please don't forget to subscribe to my YouTube channel and hit the notification bell for more updated contents. And I will be more glad if you like this video, leave a comment, and share with friends. So let us begin this math lesson now. Dear Math Buddies, again, welcome to my YouTube channel and thank you for watching my content. And to start, let us define a combined variation. Combined variation is the kind of variation that involves both the direct and inverse variation. It is also the involvement between the joint and inverse variation. So this statement that represents our combined variation is z varies directly as x and inversely as y, which is mathematically can be translated into z is equal to kx all over y, where k is the constant of variation. This time, let us now translate statements into equation. Let's have our first example. T varies directly as a and inversely as b. From this statement, our three related variables are t, a, and b. With this, we can translate this one into equation as t is equal to ka all over b, where k is the constant of variation. Another example. Y varies directly as x and inversely as the square of z. Our three related variables are y, x, and z. But please take note also that we must be particular with the statement, the square of z, which is very essential in translating our statement. So we can write this one as y is equal to kx all over z squared, where our denominator z is raised to the exponent 2 because of the phrase, the square of z. Another example. W varies jointly as c and the square of a, and inversely as b. From this given statement, we are having four related variables represented by w, c, a, and b. So we can write this statement into w is equal to k c a squared all over b, where a is raised to exponent 2 because of the phrase square of a. And from this given equation, k represents the constant of variation. Another example. The pressure P of a gas varies directly as its temperature T and inversely as its volume V. Our three related variables are P, T, and V. So we can write this one into P is equal to KT all over V, where K is the constant of variation. So we know already on how to translate our statement into equation. This time, let us try to solve for the constant of variation, which is represented by k. Let's have our first example. If z varies directly as x and inversely as y, and z equals 9 when x equals 6 and y equals 2, solve for the constant of variation. From this given statement, first thing we need to do is to translate statement into equation. Remember that the first statement will help us determine our equation. So if z varies directly as x and inversely as y, this can be written as z equals kx all over y. So after we translate our statement into equation, we will simply substitute the given and solve for k, where z is equal to 9, x equals 6, and y equals 2. We will have 9 is equal to k times 6 all over 2. Then let us simplify by applying cross multiplication as we multiply 9 and 2. So we will have 9 times 2 is equal to 6k. So to simplify, we have 18 is equal to 6k. Since we are solving for k, we will divide both sides of the equation by 6. To simplify, 18 all over 6 is equal to 3. So we have 3 is equal to our constant of variation. Let's have our second example. If p varies jointly as q and the square of r, and inversely as s, find k if p equals 40 when q equals 5, r equals 4, and s equals 6. Again, in solving for our k, first thing we need to do is to translate our statement into equation. And the first statement will help us determine our equation. So if p varies jointly as q and the square of r and inversely as s, we can write this one into equation as p is equal to k q r squared all over s. R is raised to exponent 2 for the reason that our statement has a phrase square of r. Then, we will substitute our given and solve for k. Our p is equal to 40, our q equals 5, our r equals 4, and s equals 6. Then, let us simplify. So we will have to simplify first 4 squared, so that is 16. Then 40 times 6 is equal to 80k. 40 and 6 is multiplied through the idea of cross multiplication, while 80k is a product when we multiply k, 5, and 16. Let's simplify. 40 times 6. The product is 240, and we will copy the expression on the right side of our equation. Since we are solving for our k, we need to divide both sides of the equation by 80. In order for us to get rid of 80 on the right side, leaving k on its place. So the quotient of 240 and 80 is 3. So our constant of variation is equal to 3. This time, let's apply our learnings as we solve word problems involving combined variation. Let's have our first example. If r varies directly as s and inversely as the square of u, and r equals 2 when s equals 16 and u equals 2, find r when u is equal to 3 and s equals 20. So for us to solve this word problem, first thing we need to do is to translate our statement into equation. Since r varies directly as s and inversely as the square of u, then we can write this one into equation as r is equal to ks all over u squared. Then, remember to use the first set of given as we solve for k. In this case, I am referring to the values of our r, which is equal to 2, s, which is equal to 16, and u equals to 2. So we will substitute this one in our equation as we solve for k. Then, let us simplify. So we will have 2 is equal to k times 16 all over 4. Apply cross multiplication as we multiply 2 and 4 and simplify the right side of our equation. So this leads us to 2 times 4 is equal to 16k. Then 2 times 4, the product is 8, that is equal to 16k. Since we are solving for the constant of variation, we will divide both sides of the equation by 16. So we will have k is equal to 8 over 16, and it can be simplified or be written in its lowest term, which is equal to 1/2. So the constant of variation is equal to 1/2. After we solve for k, the next thing we will do is to solve for the unknown variable. In this problem, we will find r. So in finding for r, all we need to do is to use the constant of variation and the second set of our given. I am referring to the value of our u, which is equal to 3, and s, which is equal to 20. So therefore, we will have r is equal to 1/2 being the value of our k times our 20, which is the value of our s, all over 3 squared, where 3 is the value of our u. Then, let us simplify. So, r is equal to 1/2 times 20, that is 20 all over 2, while squaring 3, that leads us to a value of 9. So, 20 over 2 can be simplified as 10. So, therefore, our final answer would be equal to 10/9. So, r is equal to 10/9 when u is equal to 3 and s is equal to 20. This time, let's have our second example. If x varies directly as the square of y and inversely as z, and x equals 12 when y equals 3 and z equals 6, find x when y equals 9 and z equals 6. From this given word problem, first thing we need to do is to translate our statement into equation. Since x varies directly as the square of y and inversely as z, this can be written into equation as x is equal to ky squared all over z. Here, we noticed our y is raised to exponent 2. It is because our statement says square of y. So we need to be particular with the exponent that is written in our equation. Then, we will solve for k. In solving for k, we will simply substitute the first set of given. I am referring to the value of our x, which is equal to 12, y, which is equal to 3, and z, which is equal to 6. So we will simply substitute these values in our equation. Then, let's simplify. So we will have 12 is equal to k times 9 all over 6. 9 is a result when we square 3. Then, apply cross multiplication between 12 and 6. So we will have 12 times 6 is equal to 9k. Then, let's simplify. 12 times 6, the product is 72, equals 9k. Since we are solving for the constant of variation, we will divide both sides of the equation by 9, which leads us to the value of our k equals 8. So, the constant of variation is equal to 8. After we determine our k, the next thing we need to do is to find the unknown variable. And in this word problem, we will be solving for the value of x. And we will use the value of our k, which is equal to 8, and the second set of given, where y equals 9 and z equals 6. So solving for x can be done as we substitute k, y, and z in our equation. To simplify, 9 squared, that is 81. So multiplied it to 8. That leads us to 648. We will simply copy the denominator. And simplifying 648 divided by 6, our x is equal to 108. So just remember the steps in solving our word problem. First, we need to translate our statement into equation. Second, we will solve for the constant of variation using the first set of given. And third, we will solve for the unknown variable using the second set of given and the value of our k. Hope this idea will really help us as we deal word problems involving combined variation. There you have it. Hope you learned something new today. God bless us all.